Okay, for geometry 7.4, we are looking at similarity in right triangles. So these are your notes for that. The first theorem is talking about altitudes. It's a little blurry, sorry about that, but what it says is the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original one and similar to each other. So it's easier to see in this picture. They have this big triangle out here, which is ACB. And if you draw an altitude from the right angle corner down to the hypotenuse side, it's called an altitude because what it does is it makes right angles on each side, and it's also the point from the right angle itself to the shortest route to the hypotenuse. And so what it ends up doing is it separates this big triangle into now three because you've still got the big one. And then when you use the altitude to cut down here to make right angles on each side, it cuts into perpendicular parts. Then you've got this triangle on the right, which all they've done is kind of rotate it around to where this right angle is now up here. So they've kind of twisted it on its like upside down, they've rotated it, and then they've taken this one and also rotated it down. And so you can see our original right triangle with the right angle up here, our tiny one that was cut over here with the right triangle up here, right angle up here, and then the medium-sized one with the right angle up here too. So you can see that all three are similar to each other. And instead of just one triangle, when you cut the altitude down, it cuts it into three that are similar to each other and similar to all three. So if you wrote similarity statements, it would be ABC is similar to ACD, which is also ACD is similar to CBD. So that's what it looks like. I kind of want you to visualize anytime you see one big triangle, it also being able to be pulled down and separated into two additional triangles. So the next part says, what similarity statement can you write relating these three triangles? And they have actually done this for us. If you look right below, they've separated the triangles. Here, let me do this. They've separated the triangles and then they've rotated them around to orient them to where they're facing the same direction. So you can see they're all right triangles, a big one, which was the original, and then the two smaller ones, which were cut on either side. So you can see. And now we can write the similarity statements. So we can write, doesn't really matter the order as long as you're consistent. So if I start here on the left and go up, ZXY is similar to ZYW, which is also similar to YXW. I probably should have put the little triangle symbol in front of each one, but that's okay. All right, let's move on and do the student try. So this is a good time for you to push pause and see if you can figure this one out in your head to write the similarity statement for all three. Okay, if you're not quite ready, I like to go, in my head, I like to say short leg, long leg, hypotenuse. So I'm going to look at the first one and I'm going to say short leg, which is Q to P, long leg, which is to R, and then hypotenuse. And that one is similar to, I'm going to look at the medium one now, this one on the right. The short leg of it would be P to S, to the long leg would be to R. And then I'm going to look at the tiny little baby triangle, and I'm going to look at the short leg, which would be QS, to the long leg P, and then back across the hypotenuse. So this is the order of those. And it doesn't matter if you didn't start with QPR, if you did PRQ, then it would be SRP, then it would be SPQ. So just be sure you are consistent. All right, the next thing you guys are learning about today is something called the geometric mean. I bet when you think of the word mean, you think of the average, and like you would add two numbers and divide by 2 or whatever, add 5 numbers and divide by 5, whatever. That's actually not how you would do the geometric mean. The geometric mean is set up in proportions. So the proportions are equal and occur frequently in geometry for any two positive numbers, like for example, A and B. the geometric mean of A and B is the positive number x when it's set up in this type of a proportion. So what you would do is you would cross multiply. So it would be AB equals x squared, and you would solve that. So, but this is the actual formula I want you to remember. AX equals x over b. So you're going to swap out the a and the b for numbers, but x and x are going to stay x. So you're going to end up with an x squared when you cross multiply. So let's look at an example of finding the geometric mean, and I hope this will make more sense. So what is the geometric mean of 6 and 15? So what they've done here is they've set up 6 and 15 for our a and b. Just like I told you, we'd swap those out for numbers. 6 and 15 are the numbers, and when you cross multiply 6 times 15, you get 90. X times x is x squared. So then in order to get x by itself, you need to take the square root of each side. And then we really need to review how to make simplest radical form, because that is something I'm going to need you to be doing. So we'll review that when we get down to this problem here. So technically, the square root of 90, I might for just a little while be okay with you giving me the decimal form of that, which would be 9.5, but it's more specific to have simplest radical form. So you would have pulled out a 9 by making it a 3, and then 10 would have stayed in. So 3 root 10 is actually the answer. So let's try this one. What is the geometric mean of 4 and 18? So again, 4 over x equals x over 18. This is how to set up geometric mean. Cross multiply, 18 times 4 is 72. 72 equals x squared, so you would root each side to get x by itself. 72, let's review simplest radical form. What two numbers can we multiply by to get 72, and one of them has to be a perfect square? So I believe 72 divides by 9. It's not probably the best one because 8 also has a perfect square in it too. So 72 must also divide by 16? No. What is a bigger square root than 9? 16, 25, 36. Yes, so 36 and 2. So that would be 36 times 2. And since 36 is a perfect square, it pulls out because the square root of 36 is 6, and the 2 stays inside. So the simplest radical form is 6 root 2. Okay, we'll keep reviewing that. All right, the next section is a corollary to one of the theorems we just had, actually. So it's hard to read, I'm sorry about that, and I'll try to zoom in a little bit. It says the length of the altitude to the hypotenuse of a right triangle is the geometric mean. It is the geometric mean. So that's why we just learned geometric mean of the lengths of the segment of the hypotenuse. So let's see what that actually means. So if you can set this up, AD over CD, so AD over CD, so what I'm looking at is short leg over long leg equals CD, which is short leg, over DB, which is long leg. So if you do short leg over long leg of the little triangle equals short leg over long leg of the medium triangle, you can set that up and find the geometric mean. If you only have 3 of the numbers, you can find the 4th one by doing the geometric mean. Okay, I believe this says kind of the same thing. Yeah, it just explains it in greater detail. So these are the 2 legs. This is the hypotenuse. So you could also do short leg over hypotenuse equals short leg over hypotenuse. It just depends on what you have. So short leg over long leg equals short leg over long leg, or you can do short leg over hypotenuse equals short leg over hypotenuse. So let's look at an example of that. They want you to write a proportion to find x and y. So actually, they've all worked this one out for you. So let's go on to the next page so that we can actually try some, but do go back and look at that if you're still a little bit confused. So in the following triangle, let's just make sure you know the vocabulary. What would be the hypotenuse of QRS? So QRS is the big one. So the hypotenuse is Q to R. So QR. The segments of the hypotenuse, which I think they're referring to the legs, the other two legs would be QS and SR. I hope that's what they're referring to. I believe so. And then the altitude. The altitude is the thing that cuts it just right into, it forms its right triangles when you cut it from its right angle down to the hypotenuse. So that would be ST. The altitude is ST. All right, and then the segment of the hypotenuse adjacent to leg QS, so the hypotenuse that's adjacent to QS, the segment, okay, here's QS, that's the leg, the segment of the hypotenuse, oh, that would be the other little mini leg in here. The segment adjacent is right next to, and of QS would be QT. Okay, I don't really care if you know these. I really want to just make sure you know how to separate them and how to find them. So we're not going to do all 6 of these because it's the same thing 6 different times. So let's just make sure you can do a couple, maybe even just one in each section. So write a similarity statement with all 3 of these triangles. So I'm going to, once again, I have a habit of going short leg, long leg, hypotenuse, short leg, long leg, hypotenuse, short leg, long leg, hypotenuse. So I'm going to start with the big one. B, A, C is the order I'm going to go. You don't have to. And I'm going to go short leg, long leg, hypotenuse of the medium one, which would be A, D, C. And then of the tiny one, short leg, long leg, hypotenuse would be B, D, A. Okay. I'll just try maybe one more of those. Let's move down here to 7. So I'll do short leg, long leg, hypotenuse, which would be L, K, J. Of the medium one, it'd be K, M, J. And of the baby tiny one, it'd be L, M, K. All right, let's skip down to 11 and practice finding the geometric mean of a couple of these. So 9 and 4, that would be 9 over x equals x over 4. When you cross multiply, that is 36, which equals x squared. Oh my goodness, thankfully, that comes out exact. X squared is 36 means that x is just 6. The geometric mean would be 6. Just for lack of space, let's come over here and try 13 since we have room off to the side. So 13 would be 9 over x equals x over 30. Cross multiply, I don't know what 9 times 30 is. Whoops, can't even see it. 270. So 270 equals x squared. I chose poorly. That's okay. I don't think 270, I don't think 270 is a perfect square. I'm going to try it and see. No, it's not. What goes into 270 so we can make the simplest radical form? I'm going to guess 9. 270 divides by 9. Yeah, we'll go 9 and 30. 9 and 30. I don't believe 30 has anything in it that would be a perfect square. So all we're going to pull out is the 9, which the square root of 9 is 3. So it is 3 root 30. Please forgive me if 30 breaks down a little bit more. I can't think of anything that would make it. 16 won't go into it. 9, 4. No, I think this is good. Okay, and then the last section down here, let's look at it. It says we're just going to complete the ratio. So Q over R is short leg over long leg. And they want something over Y. This is long leg. So short leg of the tiny one over long leg of the tiny one is T. This little section. So short leg over long leg equals short leg over long leg. So it has to be T. Okay, I believe we have another page to look at. Nope, just kidding. The next page is your practice test. So if you want to try a few more of these, you can. I just wanted to do a few examples so that you are on the right track and ready for your practice homework.